Amazing. So, first and foremost, thanks both of you for giving a talk. It was their first talk, as far as I'm aware, at least publicly. Are you speaking before at conferences or meetups?
In Russia.
Doesn't count.
First tech talk, actually, for me, yeah.
So, second show of hands, because that's actually not easy. And a gentle, subtle reminder that you can also give your first talks, and the man to speak to is Roberto, sitting there in the shadow. Other than that, before we get into the specifics of what you talked about, neither of you has actually touched on your origin story, as in what actually brought you to Rust in the first place.
Well, yeah. So my background is mostly in Ruby for a long time. But then one day I realized that it's not something I really like. It's not the technology I want to continue with. It was like maybe 10 years ago, and I started to search for something which I like more. And I passed through many technologies, Golang, Clojure, Erlang, things like that. But I always had feeling that I need something which is strict enough and which guides me in building the code properly. And one day I found Rust, and it's actually in that the love happened. So I actually realized that it is what I was searching for.
I did see some of the scars of a person using a dynamic language in your Clippy setup. I was like, this person must have come from either Python or Ruby. And I was overcorrecting on the other side.
Yes, yeah, I agree with that.
What about you, Matilda?
Yeah, I'll lean into Gleb's story in the sense that I also started with Ruby or Rails. And but I was always searching. Like I found articles which said that it's a good thing to learn other programming languages. So I went that way. I wanted to learn other programming languages, and then I figured out that I don't have a computer science background. I felt like I have some catching up to do, and some really great algorithms courses are in Java. I wanted to brush up my Java. I have an engineering degree, but not computer science. So I brushed up my Java and got kind of hooked on Java concurrency. I thought that was the holy grail. Maybe not. It's actually quite tricky. You have to read. You have to read to do it correctly. With Rust, you also have to read to do it correctly, but it's still different and better. And yeah, it was in 2017. I was heartbroken. All of a sudden, I had a lot of free time. I read the Rust book, because what's better fix for heartache than learning a new programming language, right? So, and I thought this is really cool, but I always also thought that it's so niche. I will never work with Rust. I need to invest on my actual career and build on that. But so it happened that about 1.5 years ago, or almost 2 years ago, I started getting managerial responsibilities, and I felt that too many meetings. Maybe it's not for me, or at least I need a hobby. I need something to, give intellectual challenges for myself. Sorry, I mean management is good work as well, but maybe not for me personally. So I started looking into Rust again, and all of a sudden things started clicking. I started feeling, okay, maybe I can be productive with this, and I wanted to see if I could contribute to something. I picked Tokyo, and I managed to find a couple of low-hanging fruits, put in a couple of commits, and with that plus gaming background plus a recruiter that found my profile on LinkedIn, I got my Rust job. So that's the story.
Actually, an interesting segue into that. How many of the people that are here today, first of all, use Rust professionally? If I can get a show of hands. Don't be shy. Be higher. It's difficult to count otherwise. Okay. Roughly 1/6, 1/5. How many of you are using Rust as a hobby, side projects and such? Most of the other ones. We get a complete Venn diagram. How many are just curious about Rust and thought it was a good idea to come here today and have a look at what people are saying? Okay, that's a non-zero set of people. Nice. So I think an interesting question based on that, because I assume a lot of the ones who are using it as a hobby might want to transition into using it professionally. And you mentioned that in your talk towards the end, Matilda, that Matchday is hiring and that Rust is one of the competencies you look for. Is knowledge on the language actually that important? What's your experience like hiring or training people for Rust?
For me personally, language knowledge is hugely important, but not necessarily for the reasons you might expect. My number one reason for asking a candidate or hoping that the candidate has Rust experience before joining a Rust experience full-time is to have written enough Rust so that you know if you like it enough. Because you need to invest in it. You need to invest in your skills. And sometimes it's work, and sometimes you need to have that motivation. So basically, for the candidate needs to know if they like Rust enough to keep investing in it and to be happy with it, because there are developers who, and I know some developers who say it, that they are happier with Python or Go, and good for them.
There was no judgment. She just said good for them.
Yeah, that's my number one reason. I hope that anyone wishing for a Rust job writes enough Rust to know if they really like it.
What they're signing up for, which makes perfect sense. What's the situation is that the Workato? Is Rust a requirement? Is Rust a nice to have?
So when we hire for our team, it is kind of requirement, but we don't necessarily require production experience with it. So mostly, I agree that, it's really hard to actually find the person who knows all the, Rust really deeply. So just ask how pin work, for example, and you will face 99% of not being able to answer that. Instead, we are looking for solid experience. We are looking for basic understanding of the language, of the core concepts. Sometimes we see people who actually they go into Rust and they think they look very briefly on it and they think oh, it's like Python, it's like C#. They don't go deeply into it. So then you ask questions, they say, I don't care, I will definitely figure out things. That doesn't work. So actually it is important, and you actually see it during the first interview, you see it within first 20 minutes of the talk that if person is suitable or not for the role. So if they are interested in Rust, even if they don't know the answer, they will go into conversation, they will tell what they know about that, they will understand what they're missing and things like that. So yeah, it's basically about, I agree, interest, invest in some time into Rust, and basic knowledge of the area.
So you touched on pin, yes, which is a fairly subtle abstraction, which I can use a segue a little bit in that direction. How much expertise do you actually feel you need in Rust to be productive on a Rust code base? And I ask this because a lot of beginners, and I speak to many at events and such, always kind of underestimate or undersell the Rust they know. I know some Rust, I can do some stuff, but I'm in no way an expert. Even after they've written sometimes tens of thousands of lines of code, just an hello word. Because Rust is a large language. If you really want to say I'm a Rust expert, and by that you imply I know everything, there's a very tall bar. But it's actually a bar, is that a bar that you need to clear? Do you find that, day to day, you need that much depth of Rust knowledge?
Yeah, I actually constantly see the same pattern, especially for beginners. Then people are focusing on something which is completely not needed for real production development. People are focusing so much on borrow checker behavior, and in real production code, if you don't write libraries, you don't really focus on effective code. You typically end up with using IRC, whatever it is, and you just don't care about most of complex concept. But what is really important is it depends on what you're writing. So since Rust is multi language suitable for different areas, you can write embed, you can write games, you can write network code, WebAssembly modules, whatever. So you should focus probably on the area where you mostly want to work in. So if you build network services, for sure you should understand how Tokio works. You should understand the asynchronous model. You should understand differences between asynchronous and blocking code and things like that. But it's not that important to understand how ordering and atomics work. It is completely different world. Yeah, most of cases. you don't need this.
What's the case for you, Matilda? Matchday?
Let's try to define productivity as hard as that may be. So for me, base productivity means that you can write something that works and it's correct, at least after a reasonable amount of hardening. And maybe it's not like horrendously ugly, maybe it's sort of readable, and maybe you complete that in reasonable amount of time. So that's kind of some tolerance levels for what productivity could mean. And we have, so in our team in particular, we are currently 3, the lead developer, myself, and then a guy who jumped from the platform. I never mentioned it, but the platform, the marketplace, is built with Python and Django. And this guy...
No shame. It's fine.
Fine language and fine framework. But it's true that our servers are just so much more effective than theirs. So
No.
And he had been tinkering with Rust in his free time. He wanted to work with Rust if possible. And he made the transition to our team with having written some hobby projects which were maybe not that great, but they worked, they did something. That was enough for him to know he wanted to make the move, and we took a chance on him. So we have onboarded somebody who did not have much idea of how to borrow. So there were a lot of clones in the beginning. I hope this is actually also streamed on YouTube.
It is.
No, but he's done a really good work, and most importantly, given that we were willing to give him the support he needed, he was productive, he was helpful for our team. And we have the experience of boarding somebody who has some Rust skills, but does not have necessarily depth. So that can absolutely be done, and we're willing to do that again if we have a nice candidate. Otherwise, yeah. Does this answer your question?
Yeah, it does. I don't want to drill any deeper. We'll maintain the colleague anonymous for the benefit of the internet. Probably this is a good moment to take some questions from the audience. If you have any, raise your hand and speak loud and clearly. So for the sake of those who didn't hear, what do you think Rust will be 5 years from today?
In the last few years, even last 5 years, I think we've seen huge traction for Rust, to be honest, on the backend development side. And I think experiences like ours show that you don't necessarily have to be Amazon or Alphabet or Discord or Cloudflare, somebody who's working at huge scale to get benefits from Rust. And so I think Rust will continue this victory march, at least on the server side.
So are you asking mostly about this Rust language and standard or market penetration? Yeah, I think in terms of market penetration, it's kind of pretty clear. So we see so many areas the Rust entered just short time ago, like Linux kernel, for example, and I believe it will grow there, and more drivers will be written on Rust. So in the area of system programming, I believe Rust will eat everything else. So basically, it will not happen fast, just because it doesn't move fast in this area. But generally, it will take more and more, bigger and bigger part of it.
Yeah, to give you a measure, perhaps 5 years ago, so 2019, async await didn't exist. If you had to write a network server in Rust, you had to do it with futures combinator, which meant you had a very high tolerance for pain. He had one, I didn't at the time. There was one conference in Europe, which was RustFest. This year, I think we had 5 or 6. Rust was used only in the most advanced, risk-tolerant organizations. You'd zoom out today, Rust is used in so many places. The most meetups in Europe no longer have a slide. We like Rust users because it's just too many logos. It's used in so many places that a lot of companies don't feel like they need to remark that they're actually using Rust. Like I speak daily, as part of my job and at events with a lot of companies that you probably know by name that are actually using Rust, and you don't know about that because like it works, we're doing it. We don't speak about using Java. Why should we speak about using Rust? Which is, that is success. When it feels like that technology choice is not edgy. It actually means that technology has gained a level of market, and technological acceptance that marks it as mature. And as Gleb was remarking, Rust is entering in a lot of sectors which are known as being slow-moving: automotive, kernel development, embedded in general. So if I was a person deciding on which technologies to invest on from a career perspective, I think Rust is a technology that's going to have a very long return on investment. Like, the technology is going to be here for decades because it's penetrating in sectors that operate on the time scale of decades. So if you are on the edge of, should I go and read the Rust book? My advice would be yes. Definitely, as Gleb was saying, read the Rust book, don't try to say, I'm going to wing it. It's not going to work. I've seen many devs at various levels of seniority just crash. Like, I don't read books, I just figure it out. I would suggest reading something. But other than that, yes, I think there's a bright future ahead. It might not totally dominate everything. It's not a zero-sum game necessarily, but I think it's going to be here to stay, and it's going to get larger and larger.
Can I ask a question?
Of course.
Yeah, so we're talking about operating systems, embedded automotive server-side development, but there are other sectors as well. And recently I've been thinking that maybe Rust is a little bit, we are behind the hype, because there are also reports and blog posts on use cases where Rust may not be that good. One such area, apparently, it's not my area of expertise. I just read the blog post and now throw the question conveniently on your turf.
I know what blog post you're talking about, yeah. But yes.
But one post was about indie game development, where you have to iterate really fast and everything has to be connected somehow, which is kind of anti-Rust. Or at least, yeah. And another topic was UX, visual user interfaces. So what do you think is the status of Rust and the future of Rust in these areas?
I'm not a game dev, so my opinion wouldn't be very authoritative. But that blog post touches on a lot of pain points that are not necessarily related to game development. And as you remarked, a big issue in Rust that's the borrow checker really likes tree structures. Like, it likes, I own this thing and this thing owns this other thing, but this doesn't go back. As soon as everything is connected to everything else, you find that the borrow checker actively fights you back. Like, it makes very difficult to build these graphs actually using references. And you try then to sidestep a little bit the borrow checker by using different memory management schemes, like arenas. That's a very common one. Where you're like, okay, I'm going to put all of my objects into one gigantic array, and then I'm going to refer to them with indexes everywhere. And that makes it so the borrow checker doesn't scream at you anymore, because it's just integers pointing somewhere. But then suddenly you no longer have that guarantee that those references are alive. So you might go into that array looking for an object that is no longer there, because the memory of the array is there, but the logical object that you're referring to might have been removed, deallocated, moved, something else. So that is a challenge, which is also coupled to some other issues related to the allocator interface in Rust, which is still kind of unstable, kind of not super first class, compared to other languages such as Zig, where like passing the allocator around is a lot easier. The issue around UX is somewhat similar to that, but not quite the same. There's actually been a lot of activity in the UX UI department. There's a lot of pretty high-profile projects in Rust. There's Lint, there's Dioxus, there's Leptos, there's Velo, and a few others, which are actively being developed. And there have been proposals coming from the UX UI world on how to make things easier. There's a very interesting, I think, blog post is going to come out at a certain point from Dioxus on what they call features they need for high-level Rust that currently are not available, which is currently being discussed in the Rust project Zulip. And a lot of those things will probably go in a very different direction from what Gleb would set up in his project, but actually made some kind of faster development nicer to do. So I don't think Rust is, even though Rust is full stack, so now even though Rust goes from the kernel to the browser, that doesn't necessarily mean that Rust is gonna, win by a landslide at every layer of the stack. I think you need to look at each vertical as its own thing. There's a Rust for game dev, there's a Rust for backend, there's a Rust for kernel, there's a Rust for embedded, and Rust is at different levels of maturity and penetration in each of these markets, and you got to evaluate the market you're interested into. So I can speak about backend, other people can speak with a lot more, experience about embedded and similar things. Like for example, backend Rust is doing well, but it's still not, the go-to language. Like if you're writing a backend server in Rust, it's still a tiny bit edgy. Like, why are you not using Go? Or like, why are you not using Java or Kotlin? So that there is work that we can do, and you touched on a lot of the things, right? You need to get a GraphQL API off the hook, and the integration with the most used, one of the most used web frameworks didn't work. And he's trying to get OpenAPI, and so he's going for another web framework, which is kind of less used, just to get that OpenAPI integration working. So all of these are, nuggets of, it works, but you need to do a lot of work. And so that is not the end state that you want for an ecosystem to say, we got it, like this is Spring Boot, go launch it. We're not quite there yet. Anyway, that was a very long answer. Sorry.
Can I add something? Yeah.
Please do.
Yeah, so I think the important part of choosing technology for these areas, game development and UI, right? It's about the paradigm which is behind the language. And currently, classical object-oriented languages are dominating these areas. So C++, C#, Java, inheritance, all these complex relationships between classes, objects, and things like that. And Rust just chose different paradigms. So it doesn't follow this. It actually prioritizes safety, pretty simple but strict structures over it. And the question is like, if it's suitable for this area. So if these decisions are suitable for the area of game design or of game development, of user interfaces and things like that, we may end up in a situation that Rust just not suitable for that. So then it won't work. But yeah, generally, I think that if game development, I guess there are some frameworks there, but nothing big. But in the UI development, there are a lot of activities actually, and pretty nice.
Oh yeah, probably one of the most visible one is Cosmic, which is the UI environment for Pop OS, which is written in Rust. So things are happening. The Z editor as well. So there are examples of Tauri is another one. So there is a lot of stuff happening. Anyway, question from the audience here. Let me summarize the question for those who are following the stream. It's like, is there an end to the number of strictness checks that you can have? Interesting, the lines have gone down.
Yeah, that's a good question. I don't feel that. So the reason is that, you couldn't measure, it's just incorrect to measure your performance as a team, as an individual, just by, figuring out the time you spend building like single pull request, for example. Because the more technical debt you build, the more bad solutions you made, bad decisions you made in the past, the slower you deliver code in the future. You have to actually refactor, you have to deal with bugs and things like that. So the more strictness you introduce in the beginning, the less, you stop facing this slowness over the time. So you kind of it's not like that, right? Really fast at the beginning and then just unable to deliver anything. You're just moving to the same constant velocity.
I actually want to go a little bit into that. You showcased throughout the talks a few examples of what I call type safety, as in domain modeling through types, which is a very nice concept that you can port across different programming languages, but in Rust works quite nicely, as in most functional programming languages. An issue I have personally had in the past with that kind of approach is that composition of guarantees doesn't necessarily scale. Like, for example, you showcase a number that should not be in 0, and you have non-zero use size. What about a number that needs to be in between a certain range.
That's a separate type.
Yeah,
You just create a separate type, macros, whatever. So we do it scale, it works. Okay. Well, in our case, it works.
Yes, is the answer. I'll take that. I think there was a question, yes. Let me repeat the question as always for the stream. So at what point something needs to go into the test rather than the language, and in particular for the copy example, why is that a problem?
Well, I think, each technology has some, soul, some, basic idea inside, and you just follow it. So, for example, if you compare, Rust with Ruby, as for example, right? So Ruby is about express yourself, build nice DSLs, do whatever you wish, it will fix everything for you. So you just follow this paradigm when you develop Ruby, and the same have the same properties. You can find same properties in each programming language. And the thing is that Rust properties are about that. So it's about how that's actually was mentioned in the first presentation, how you refactor. It's so nice that you can take the core structure in Rust, change some attribute there, and start a huge refactoring from that. You just run the compiler and see all the errors which appears, right? And then you just follow what compiler says to you. And it actually guides you to build good architecture, which is the most important part of the development of Rust. And not only in Rust, actually Rust just maximizes that. So that's why I think it's important to continue building in this safety and strictness mechanism into Rust compiler. But you always find there always be a limit. In order to go beyond these limits, you introduce more and more things, which goes from maybe other worlds like fuzzing. It came from C probably mostly. So we continue improving our application with these instruments.
There's also various kinds of checkers that you can run. There's Miri, there's various kinds of verifiers. Kani is one of those, but there are others. So there's a lot you can deploy on top of the type system to kind of prove correctness of your programs. I think there was an hand raised in this area, but I might have dreamed it. So would you write an MVP in Rust, or would you use a faster iteration language? Let's give that Matilda.
Right now, I would go with Rust, because having been immersed in Rust now for some time, even when I look at the .NET stuff, it looks alien. It's so different. So once you get past the threshold of feeling good with Rust, feeling that you know where to put things and so on, I think it's as good as any other language. I think for fast prototyping and MVPs, a full stack framework, such as Ruby on Rails or Python Django, may have its benefits if the idea is that the same prototyping team builds both the backend and the front end, and all you want to do is to validate a concept or validate if you can get users for your server or for your service, and then you worry about scaling later, basically. That's the traditional story, right, for MVPs. So if you need a full stack framework, maybe Rust is not the choice. It's at least that it's not the only choice, let's put it this way. But for server, if you feel happy with Rust, go for it. Build with Rust.
I guess another way to phrase that is that actually it's not Rust the language that's the issue. It's more the libraries that you might or might not have in one ecosystem compared to the other. Like if you move your question to something like artificial intelligence and machine learning, you'd probably be a lot faster with Python, not because Python is inherently a better language, but just because it has a lot more libraries. And so you don't rebuild as much stuff. You just do the thing that you want to do.
Yeah, and also choose whatever works for you the most. I mean, if you know Python, choose Python for MVP. So there is no reason to do anything else, actually. If you want to use this MVP to learn Rust, then go ahead and do this.
To summarize, is there a difference in the way you operate a Rust service in production? So observability, deployments, CI, I assume as well?
In terms of libraries, so typically you need something like Prometheus, OpenTelemetry, what else? Sentry maybe, and things like that. So everything is there. So just take the necessary crate. They are stable. They are good. They are working. So in terms of like, for example, Kubernetes, so you will need to build the image, and basically it's not really related to the programming language, right? So you should just you should just implement some guarantees, like how you react on signals, how you initiate graceful shutdowns, how you control ready and liveness checks in your applications, and how properly you integrate it with Kubernetes and things like that. So generally, since what I talked, we are very reliability part is very important for us, and we don't face any issues in here. So
Yeah, when you use images or containers, the virtual machine does not really care what is being executed as long as the recipes work, so to say. One difference we notice is that our marketplace needs a lot bigger servers than our Rust game servers. So we notice that difference definitely. So Rust is more resource efficient.
I think a few more things to note there. I think one big difference is performance profiles, which is not really about being faster or slower, it's about being less spiky. Since Rust doesn't have a garbage collector, most Rust services under constant load will have more or less constant performance. And that makes it a lot easier to design alerts, or generally to detect, even looking at a dashboard, when the system is behaving abnormally. Very often, at least in my experience working with GC's language, you look at a spike in latency and you second guess, is this a problem? Is this something I need to engage with? Instead, in Rust, if you have a service with a certain performance profile and suddenly latency goes 4x, you have a problem. It's just a fact. And so you go in and try to troubleshoot. On the other side, so not on the as positive, some of the technology that has been perfected over the past decades for languages like Java or C# is not available for Rust. If you want to profile your application in production, that's not going to be as easy. If you want to take a memory dump, and then open it in a fantastic tool and look at what was there, equally not very easy. So the observability tools, metrics and logs, all this kind of stuff is going to work beautifully. But if you need something a tiny bit more sophisticated, it's not quite as the rosy story yet. Now, most applications never need that, but if you do, know what you're signing up for.
Yeah, I also wanted to add a couple of points. So it's also important with what you are comparing this, because, for example, if you take Erlang, it's just beautiful in terms of how you can debug it, right? So you can attach to the REPL, and it's actually full cluster. You have all access to internal structures. You can debug something on real production. So this is like a very specific to Erlang, for example, right? We don't have this in Rust. Probably the best thing we have in Rust is Tokyo Console. But yeah, it's kind of not
big difference.
Yes, there's a big difference.
It's a big gap.
Yeah, and another point is that if we compare Rust with, for example, Python or Ruby, it's not like completely comparing Rust. It's like Rust plus ecosystem with what we have in Ruby, for example. So it's significantly easier to run Rust because Rust application is self-contained. So there is a web server inside. You build whatever you wish, TLS termination, so anything is like really easy. With Ruby, for example, you need to run some Nginx as a sidecar, all these things, which is really painful. So, yeah. So in this sense, like, it's better.
I think there was another raised hand somewhere. Yes.
Yeah, so different projects have different patterns. To be honest, not sure if I can share exact numbers. These are internal projects, so I would be.
Most people on a panel would respond like that to the question you pose, like an answer.
Yeah. But yeah, absolute numbers. So I'm not committing on that. But regarding the designing for spikes, yes, that happens. So we can face some clients which produce like 10x load compared to something average. and we always design for that.
But I think none of that really affects the Rust side of things, right? Like most of the design for scale and bursts is around how you scale, data stores you use, like, which wouldn't change that much between one language and the other.
There are some aspects which you should always pay attention to, like for example, memory consumption. So as I mentioned, like for example, we can end up, so if you're not designing things properly, we can end up generating like 300 megabytes JSON. So which is not really good. Right? So it will just block the runtime and, you know, and consume all the memory. So with multiple parallel requests. So we should take care about this. We should care about yielding and, you know, not executing blocking operations in Tokyo and things like that. Limiting pools, you know, like actually a lot of aspects should be covered in the application, but also a lot should be covered in architecture-wise in terms of like external components, databases, things like that.
Any other question while we wait for the food? Do you know or see?
You know, and see.
Do you know and see any programming language that's coming up that might compete with Rust? And there were some suggestions from the audience, but let's see.
I believe Zekas is the one. Then I don't remember the name. There is another interesting like early stage language specifically for machine learning. Which one?
Mojo.
Mojo. Yeah, Mojo is interesting for machine learning because Rust, I guess, it's not there. I don't know.
I'll be honest and say that I don't have anything to add on this topic. I'm just happy with Rust for now. Not looking to the next if the lawn is greener on the other side.
I am, you know, I'm a little bit of a language nerd, so I keep tabs on what's happening. I think there are languages coming up like Zig, Mojo, June, who compete with Rust in some specific niches, but I don't quite see another language that's coming to Rust competing across the full spectrum. I don't see quite anything else in that direction.
I think any new language entering the space will face the same ecosystem questions as Rust is facing. So that is kind of an evolutional topic that either needs to be solved by a tech giant who wants to invest in a specific language and put a lot of resources in building that ecosystem for them, or we have the same kind of a very, very diverse, sometimes patchy kind of an ecosystem that Rust has, where all the flowers can grow and flower, but yeah. So that would happen with the new contender language as well, and then of course, yeah. So maybe this is a likely scenario that there will be more niche languages even.
I think so. I mean, most of the languages that are coming up are niche in some definition, right? The whole existence of Mojo is I want to take a bunch of Python code that looks like Python, and I'm going to build a superset, and that's going to make it so that a bunch of AI stuff is going to run faster, and you will not have to retrain basically your machine learning developers. That's extra niche, but you know, as a market.
I also want to add that, in my opinion, we shouldn't treat Rust as a kind of a standard just like that. It's not just like a syntax, grammar, or things like that. So the biggest part of Rust is actually how decisions are made, how it's growing, how it's keeping its backward compatibility and things like that. So even if we see some language which are fast enough, maybe they have some good, interesting concepts inside. But the big question is, can they grow properly within years and keep backward compatibility, keep being not introducing some backward incompatible changes. Like for example, we see this Python thing like Python 2, Python 3, right? They're incompatible, and this is a big issue. Now maybe not an issue anymore, but it was a big issue for a long time. And so somehow Rust grows properly. So somehow they can make decisions where backward incompatible changes are not introduced as addition things, things like that. So they are just great. And this is important. And in order to compete with Rust, you should also cover this, not only like build nice syntax.
The caveat to that is that it mostly applies to the standard library. I wouldn't quite say that the ecosystem is at that level of like rock solid, never make backward compatible backward incompatible changes.
Semantic versioning works.
Yeah, it does, but you remember when Tokyo went from 2 to
0.2? Yeah, that was short periods. 0.
That was a seismic shift. You had to update everything, and we've been through similar kind of seismic shifts over the years. So
I remember I created pull request and request to update to Tokyo 2.0. It took one evening.
Well, the problem is that you need to do that across 200 dependencies. Like I remember we had a Jira epic. It was like update to Tokyo 1, and we tracked all the different libraries to make sure that we could actually update applications. And this is going to happen again, right? Like Rust, the language evolves in a backward compatible fashion. But when new features, enter the picture, then libraries redesign to use those new features, and sometimes they break their interfaces, and then this has ripple effects. So stability comes with a caveat, I think. The language is stable. The ecosystem depends on what you're building on. Although a lot of stuff is releasing 1.0. Embedded HAL has gone 1.0, Tokyo has gone 1.0, so we're seeing...
I think they have some guarantees about not changing interface for 5 or something like that.
Oh, it almost expired, by the way. I think we're at the end of that LTS. I don't see Fran anymore, so I don't know what's the situation with food. I'll keep going with questions. We good? What's the situation with food? Cool, beautiful. So we can take one last question, and then we're gonna wrap up the panel. Everyone's like, I'm just gonna, no. If there's one last question, I'll take it now. Otherwise, I'll happily lead you go towards the banquet. Everybody decided the question is not important enough to be between this room and that food. So thank you everyone for attending. Thank you again to the speakers for participating. Nice to have you here.